As always, no network video or training or anything is complete without network layers. You'll find that everywhere. The first thing they always teach is network layers. But I don't really want to put it first because it's very confusing. I think it's actually, when you start with that, you can be more confused and actually understand stuff. That's why I took the routing and the other things first. And now when I explain this will bring everything together. We've explained so far. Okay. So when an application wants to send data to another application, because in essence, what networking is, it's not connecting one PC to another PC. It's connecting one application to another application. Okay. No storing. So this is where the network layers comes in. The first level is your application. So if an application wants to send data to another application, obviously you open up a connection, you do all sorts of stuff in the application and you send the data. Now, this data, how this data is actually packaged. So it actually goes to the packet levels, these layers. That's technically what this is. So if they talk about network layers, it's actually your packet. Each packet that gets transmitted, what layers they have on it. Those whole onion principle. The first layer is your application layer, which is actually your core of your payload. It's right in the middle. It's the actual raw data you want to transmit. Let's say you log into a server and you send a username and password. Actual username and password, that will be your raw payload that you want to transmit. That obviously needs to be in some sort of presentation. Typically, if you're logging into a website, you're using the HTTP protocol. And that is your presentation. So actually wrap that in an HTTP post. And put username in the username password in the post section. So it wraps it there. So actually, the username password in the middle, and just outside it will be your HTTP. HTTP will actually put stuff in front and behind. The HTTP wrapping. Then there's the session, which mostly refers to as the port number. Which is basically telling you which application this should go to. So your operating system, as soon as it gets this packet, it receives it, looks at the port, and it knows which application to give this packet to. Because obviously there's multiple applications running on any PC at any time. A lot of applications actually, like 100 or so. So yeah. These three levels are a lot of times seen as your data section, your payload section. Because it's very manipulative. You can actually do a lot of changes there. You can almost set it up your own way. Okay. Because in your app, you can change a lot of things like that. In your application, you can define a port number and use it. You can't actually define an IP because that is preset by the operating system. You see, but you can actually define the port number. So anything you can almost change is in here, the first three layers and your data layer. So yeah, basically the port I think is actually in front. The next one is the transport level. That's where your protocol comes in. I don't actually mention it here, but that's actually your TCP or your UDP, or your ICMP or whatever. So it gets packaged in that protocol. So that'll actually add extra layers around it, depending on what type of protocol it is. If it's UDP, if it's TCP, they usually call it headers. So you can actually Google TCP/IP headers, and then they'll actually say the TCP/IP header is typically, I'm guessing now, but I think it's 56 bytes. 56 bytes long. The header means it's on the front, and the tail is at the back. So the header is so big and the tail is so big. And that's all the CRC checking and the sequence numbers and that type of stuff gets stored into. Also sometimes called the segments. The next one is the network layer, and that's where your IP comes in. That's why UDP and TCP both use IPs. That's because they actually get specified above the network layer. Because they're both actually IP protocols. I don't know why they don't call UDP IP, but TCP they call it TCP IP. But anyway, technically UDP is UDP IP. Because it also runs on the IP protocol. And yeah, that's basically just where your IP address and stuff is attached. It's not just that. You must actually Google all of these layers, and they'll actually tell you all the other stuff. There's a lot of other stuff also added. But the important ones is the ones I'm going to mention. The data link, which they basically call it frames, that the encapsulation that takes place there is the MAC address. Because now, if you look at your physical hub and stuff, your hub, not a router, a hub that you just plug between multiple pieces and it just works. It actually uses MAC addresses, not IP addresses. So in the packet, there'll actually be a MAC address. Then it knows, oh, transmit this packet to that MAC address, and it will transmit it there. It doesn't use IPs. Okay. Obviously, as a packet travels through the internet like this, the MAC address might also change. Okay. Okay, then there's obviously the physical one, where it physically transmits this bits on the actual wire. That's the last layer. Where technically, there is also wrapping that takes place. They call it basically your signal and controls. So you would check that the line's empty, so you would send bits and stuff and wait for a time to send. You say, cool, start of transaction, you'll send the packet, end of transaction. So technically it does send stuff in the front and the back. So each of these things is actually layers. The topmost one sits in the middle, and the bottom one is actually on the edges, okay, of this long string of bits and bytes. That's actually what this thing means. So if you send a packet somewhere, it'll start there, it'll go down this layer to that one, 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 to that one. As it goes down, it grows, it adds these layers. Then the whole thing gets transmitted to wherever it needs to go. And then it removes these layers, it strips these layers off, and it goes back up until it reaches application. Okay, so that's where these network layers come in. You'll see I've also made mention of where gateways, NATs, VPNs, and proxies function. You'll see a gateway actually operates on this layer. So what it will do, as soon as a packet reaches a gateway, it will actually read these layers, and it will just forward it from there. Sometimes, obviously, we'll read the the protocol layer as well, depending on what the type is. NAT obviously will go up to the port section because it needs to have those translation. It needs to actually translate those, so it actually strips. If it goes through a NATed router, it will actually remove everything from here down. It will remove and add its own stuff, and then forward the packet. You see, so it really strips all the layers off until only those two remain, and put it back together again and retransmit it. Okay. So yeah, that's basically how it works. You'll also come across the term interfaces. Interfaces basically just mean network cards. Basically, almost like a trunk that goes out of your PC. You can have more than one network card in your PC. You can have virtual trunks as well. A VPN is a typical example of a virtual network card. So if you do, I know in Linux IF config, in Windows it's IP config, but that's actually wrong. Because it doesn't actually print out IPs, it prints out interfaces. So Linux actually did it right by calling it IF config. It's actually interface config, not IP config. So yeah, but you'll see you'll get a lot of virtual interfaces. If you install a virtual machine, it'll add virtual interfaces. If you install a VPN, it'll add virtual interfaces. It's almost like network cards. It's almost like the operating system thinks it's a network card, but it's not really. And it can add subnets in there, which is completely virtual. Okay. Okay, now obviously it's a port application. So that's how the operating system. So the operating system actually goes up till there. So everything down that gets handled in the operating system. As soon as you're above that, that gets handled in the OS. The application, sorry. So the OS handles the bottom part and your application the top part. Depending on what libraries you use. Obviously some operating system supports some of these presentations natively. So if you just do a call to the operating system will do the rest. But in essence what happens is the connection goes there. As soon as it gets there, it gets the port number and then it knows, this port needs to go to that application. Then the OS will give you the packet. And then your application can open it, extract the data. Okay. Does anybody have any questions?
What's the encryption?
Encryption is usually on this layer. Yeah, compression. Oh, there, I actually said NC encryption. So if there's encryption, it's usually in the presentation layer. Everything below that is just raw data. It's never encrypted. Because everybody along the route needs to know what it is. So you actually can't encrypt it. Because otherwise, because this is used for routing for getting this packet from the one application to another application. So people need to open it. People we need to know what it is. Usually just the payload part, except the port number. The payload part is actually encrypted. Okay. Any other questions?
I noticed that you put proxy there as part of the application there.
Yes. That's what a proxy functions on.
Okay, so a proxy would open up everything up to the application before you would actually.
Yeah. So if it gets a packet, a proxy typically listens on a port.
Okay.
It's different to a NAT and a gateway. A gateway doesn't listen on a port. A NAT doesn't listen on a port. It technically listens on all ports if you want to see it that way. Not on a specific port. Where a proxy usually listens on one port. So a proxy can also function there. I mean, because most proxies, let's just do that as well. Because most proxies do. I mean, if a proxy will do HTTP proxy or FTP proxy, it will only be that. So it will only be very specific. But I'm still going to get to that. Okay, cool. Okay, is there any other questions? But yeah, just to carry on with that. If it's a gateway, it'll open the packet up to there. To read the packet up to there. And the rest will leave untouched. Or not untouched, it won't even read it. Because it's not necessary to read it. It just retransmits it. NAT will all go, and NAT and VPN will go all the way up to there. Open the packet all the way up to there, and then retransmit it. Proxy will go all the way up to there, or even there, and forward it. Okay, I think let's change that. Because it actually makes a little more sense if it's there. Yeah, proxy will open it all the way up to there, and then forward it. Okay, cool. Does it make sense now?
Yeah.
Awesome.